These notes are going to cover piecewise functions. You should have this packet already printed out so you could follow along and graph and learn how to graph accordingly for piecewise functions. Okay, once you have the packet, let's look at part one. We're going to graph each of these functions and identify whether or not they are a function, and then evaluate some of our functions at specific points. So a piecewise function is exactly that. It's pieces. So when we're putting those pieces together. So if we look at part one, we look at the fact that there are actually two pieces here. There's x plus 5, and then there is negative 2x minus 1. So there's two different lines that are made up for this picture. And we also have now also two different domain values. So this domain and this domain. So first in red, we're going to look at x plus 5, but our domain for x plus 5 is only the numbers up to negative 2. So negative infinity up to negative 2. So therefore, when we graph this line x plus 5, which everybody here should know how to do, we are going to look at, okay, well, what does this graph, this line, we only want the piece of it from negative infinity to negative 2. Well, negative 2 is here, and that's where this function is ending on the right. So if we plug in negative 2, and we evaluate f of negative 2, oops, we're going to get negative 2 plus 5, which is equal to 3. So at negative 2, 1, 2, we go up here to 3, and I'm actually going to put an open circle there. Why is that an open circle? Because in our domain for that particular piece, negative 2 is not included. Our slope is 1, and now the graph to this actually goes to the left. So from here, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, so on and so forth, and try and draw as straight a line as I can. Oh boy. So it looks something like that. Oh. That's better. So that's the piece of our function. This is x plus 5 from negative infinity up to negative 2. Well, at negative 2, our function is using the equation now negative 2x minus 1. So I'm going to plug in, well, what happens when we plug in negative 2 and subtract 1? This actually becomes 3. Right? 4 minus 1 is 3. So at 3, I'm actually going to close in this circle now because for the blue graph, this actually is included in the line. So now our slope is negative 2, so we go down 2 over 1, down 2 over 1, down 2 over 1, so on and so forth. And we can connect these points, and that is the second piece of our function. This is negative 2x minus 1. So combining both of those lines and the two separate domains that we have, you have just graphed a piecewise function. Is this a function? Use your vertical line test, and the answer to that is now, of course, going to be yes. So it is a function. Evaluating our function. Well, what about f of 3? To evaluate our function, we have to figure out, well, which piece of this is 3 a part of? Well, 3 is greater than negative 2. So since 3 is greater than negative 2, we are actually going to use the second function in the list and now evaluate negative 2 times 3 minus 1, and we end up with negative 7. If we looked at our picture, we go to 1, 2, 3, we can correspond 1, 2, 3, 4, 5, 6, 7. There's our actual point. Not always will you find a point on the picture, but in this case we do. For negative 4, well, negative 4 is now less than negative 2. So the negative 4 would be part of the first graph, so negative 4 plus 5, and this would give us a value of 1. So negative 7, 1, and now if we plug in negative 2, we actually did that before. Negative 2 is part of the second graph because it's included in that domain, so therefore we know that that number is 3. There's your first piecewise function. After we evaluated this, we're going to also add to our list domain and range. So the domain of our function. Now that we have a whole picture, go left to right, you should be able to see that our domain contains everything from negative to positive infinity. Our range, bottom to top, putting this all together. Our lowest values at negative infinity, and where we do stop when we get to 3 at the top for our domain. And this has a value of 3. Okay, so there's your domain and your range for piecewise functions. Our second example, again, also has two pieces. 2x plus 1, now greater than or equal to 1. And we want to evaluate x over 2 minus 3 when x is less than 1. So doing one graph at a time, and we're going to stay with this color. Doing one graph at a time, let's look at 2x plus 1 when x is greater than or equal to 1. You are going to first plug in 1. When we plug in 1, we get 2 times 1 plus 1, which is 3. So we'll go to 1, 1, 2, 3. There's a point, and I'm going to color it in because in our domain, it is included. Now from here, we want greater than 1. So we're going to the right. Going to the right, our slope is 2. We can then plot the points and the slope from here. And that is your graph for the first one. For this second one, x over 2 minus 3 when x is less than 1. Okay, again, you are going to plug in 1. And finally, we get 1/2 minus 3, which is negative 2.5. So at 1, you're going to go down 1, 2.5, and I'm going to put an open circle right there. Right? It is not included, but it is the endpoint that we need to show. Now from here, our slope is 1/2. So I am going to go down 1 over 2, down 1 over 2, down 1 over 2, and you can keep going if you want. Connecting these points, that is the second piece. So our x over 2 minus 3 traveling up to 1. Right, this is our value of 1. So therefore, you have now two pieces to this that aren't connected. The first graph, they became connected. Second graph, they aren't connected. Is this a function? The answer to that is a yes. You don't have any repeated x values. At 1, there's a closed circle and an open circle, and that's okay. Right? They just can't both be closed. All right, so let's evaluate now our function at negative 2. We evaluate at negative 2, we are using the second function. So we're doing negative 2 over 3 minus 3. And we end up with a value of negative, what am I doing? Oh, no, that's over 2, not 3. I apologize. This is 2, so negative 2 over 2 minus 3 gives us a value of negative 4. And we can see that on our graph. At negative 2, we do have a point here at negative 4. When x is 6, evaluating the domain value of 6, that is part of our orange graph. Right, so we plug in 6, we get 2 times 6 plus 1 gives us a value of 13. Off the graph, but that's okay, we can still evaluate. And last but not least, f of 1, 1 is only part of one of these two functions. It's only part of the orange one. So we're going to take 2 times 1, add 1, and we already know that this has a value of 3. Okay, this is included in the first line. Okay, so you do need to be very careful. It's in the first one, so you can only evaluate it for the first one. Okay, based on this picture, we have two separate pieces, but that's okay. They're not connected. That's okay. We can still find the domain, and we can still find the range. What is the domain for this? If we go left to right, all of our x values are used, so this is another domain of negative to positive infinity. Our range, however, has a break in it. We go bottom to top. We're going negative infinity up to negative 2.5. At that point, we have to stop our range and jump over all of our numbers until we get to 3. And now we include 3, and the graph travels to infinity. So domain and range, your pieces and parts, all included. Okay, number 3. Expanding this in number 3 to 3 different equations. That's okay, just an extra little piece. The first one, we're going to graph in green. So now we're going to plug in 0, and we're going to get 0 plus 4. So that's 4. So at 0, we go 1, 2, 3, 4. And this is a closed circle because 0 is included. And our slope is negative 1. So we're going to go up, up 1, over 1. And have these points here. And that's that part of that line. Perfect. Second one, 2/3 x over 3 minus 1. Now we have just a short piece from 0 to 5. So we want to evaluate both ends. This one, I'm going to come over here. We have to plug in 0. And what do we get? We're going to get 0 over 3 minus 1, which is negative 1. So at 0, negative 1 is down here, and it's going to be an open circle. We have to plug in the other end. We have to plug in 5. So we get 10 over 3 minus 1. And we end up with 2 and 1/3. So at 5, 1, 2, 3, 4, 5, we're going to go up 2 and 1/3. And this is going to be a closed circle. So this segment looks something like that. For the next one, 2 when x is just greater than 5. Well, 2 is a horizontal line. 2 is here, but at 2, it's not included and just goes to the right. So we have that horizontal piece going all the way out to infinity. Is this a function? Yes, this is a function, right? If we go vertical line test, our closed circles are over or above an open circle, and that's good. For our function values at negative 2, you can look at the picture, and at negative 2, we get 1, 2, 3, 4, 5, 6. We do get a value of 6, or you plug it in, negative 2. We're going to put negative, negative 2 plus 4, and that's going to give us 6 as well. F of 0, we evaluated 0. It's actually only part of the green graph, and that's equal to 4. At 5, we also evaluated 5, and that was our 2 and 1/3 from the second line. Domain. Evaluating our domain. Left to right. Are there any breaks left to right? No, there aren't. So this domain is still negative to positive infinity. Our range. There are 2 parts to our range. Our range first starts at bottom to top. It starts at this blue at negative 1, not included, and then travels up to 2 and 1/3. It then starts again at 4 and goes all the way to infinity. Number 4. Number 4. We look at number 4, our first graph of negative 3, which is a horizontal line at negative 3. We're only looking at that from negative infinity up to 3. So we're going to plug in 3, 1, 2, 3. We're going to be here at negative 3. But our line is everything to the left. For our second function, red. Let's go with purple. Our 2x minus 5. Let's plug in 3. What do we get? 2 times 3 minus 5 is a value of 1. So at 3, we have an open circle here at 1. Our slope is 2, so we can go up 2 over 1, up 2 over 1, and create the rest of that line. Evaluating our functions. -4. -4 is part of the red, right? It's less than 3. So our function value is equal to -3. F of 0 is also less than 3. So our function is still -3. And at 3, our function is still on the red line, which is at -3. Our domain. The domain for this function. Left to right, any breaks in between? There are not, so this goes to negative, positive, infinity. What about our range? Bottom to top. Where does this start? This starts at -3, and that's it, and then jumps up and starts again at 1, which isn't included, and travels all the way up to infinity. Okay, part 2 of our piecewise functions, we just talked about graphing them. Now, what if we have a graph? Can you come up with the equations for the pieces? The first thing when you look at, when you see a piecewise function, is you have to figure out how many pieces are you actually talking about. In this first one, there are 2 pieces. There's one on the left here, and then there's another one on the right here. They do not have the same slope, so they are equations of 2 separate lines. So now we're going to write the equations for them. If we look at f of x, and to write this, just as we saw them before, f of x, and then you have your bracket, we have to fill in what 2 equations we have. Well, let's do the green one first. And we're looking to find the equation for this particular line. The equation of a line, remember, y equals mx plus b, right? Because we're plugging that in for f of x. What is the slope of this line? The slope of this line is 1 for the green. So what, the slope is 1. What is your y-intercept? It is 0. So this function is x if, now what is your domain for this? This is everything from negative infinity up to 0. So x, does it include 0? It could. You could put it in this one. There's an overlap contained at this point. It doesn't matter which function you put it in. And I'm going to put it in the green one because that one is first. The second function, mx plus b, what is your slope this time? Rise over run. And you should be able to see that it is 2x. And what is your y-intercept? It is 0. And our domain is now greater than 0. You need to be very, very careful do not put equal sign on both. If you do, it is not a function. It can only be on one. Okay? All right, the second function, or the second picture, number 8, is also made up of 2 separate pieces. Those 2 separate pieces, we need to create 2 different equations for. So f of x, make it nice and big, so we have 2 different lines. So on the left, before we'll go with green, this one I'm going to write out in green. The difference between this function and the last one is, well, we don't have our y-intercept. Can we find our slope? Absolutely. Our slope is equal to 1. So 1x, but what is our y-intercept? Well, from here we can actually count up, and we'll see that it's actually equal to 5. Right? And this is if x is less than -2. I'm not putting the equal sign in there because it is not a closed circle. It's an open circle. All right, the second part, this one red. This line at the bottom has a closed circle and travels horizontally. This is a constant function. The number is constant for -2, and the domain is when x is greater than or equal to -2. Right, it's equal to because that is a closed circle. Okay, number 9 and number 10 are both made up of 3 different parts. So first, let's look at the 3 different pieces. We'll go with the first one on the left. We're going to make it green, looking, and we always travel left to right, so we are going to write our equations from left to right. What is your slope? Your slope is 1. What is your y-intercept? Well, it's not drawn quite yet, but if we extend it, we'll see that that's y-intercept is at 2. And this is if x is less than or equal to -1. Right, we've just traveled up to -1, and there's a closed circle. All right, the next line is this little piece right in here. That little piece in there, what is your slope? Your slope is also 1, so it's just x, and your y-intercept is 4. No, it's not. It's, yeah, 1, 2, oh no, that's 3, I'm sorry. It is 3. And this is if x is between 2 numbers, -1 and +1. And since there's open circles on both ends of those, we have just less than for our interval. Last but not least, we have our piece on the right. Slope also 1. Y-intercept, if we go back a little bit, you'll see the y-intercept is at +1. And this is when x is greater than or equal to +1. Okay, so those are our values, our equations with the specific domain values. I'm going to make that smaller. Okay, our next equation and final one, this third one, has 3 pieces to it as well. The first piece on the left, this equation, right? We can figure out the slope, right? Our slope is equal to what? 3. So it's 3x. But finding that y-intercept becomes a little bit more cumbersome because we can't see the rest of the y-axis. So how do we do that? Well, we're going to remember, hopefully, point-slope form. We look at point-slope form. Which is equal to our slope. No, hold on. Let me do it this way. y1 minus y times equal to your slope times x1 minus, no, let me just, y minus y1. I'll do this way, x minus x1. Okay, so you just need a point, which is your x1, y1, and you need a slope, which is m. So you do have a slope. The slope in this case is 3. Now, what is the point? The point can be any one you see. I'm going to use -2, 1, 2, 3, 4. This point right here is -2, 4. If we use that point, -2, 4, we're going to plug in y minus 4 equals 3 times x plus 2. Simplifying this, y minus 4 equals 3x plus 6. So y ends up equaling 3x plus 10. So this number here is a 10. This equation now is for that particular line. Okay, so that's a way to do it if you don't see everything or you can't extend past the graph. You can just easily use point-slope form, something to keep in mind. Okay, so our domain for this is now from negative infinity up to -2. So x is less than or equal to -2. I'm going to put the equal sign there. It's a connected point. I'm just not going to put it in the next one. The next piece is a horizontal constant piece. Right, that's this right here. The constant is at 1, 2, 3, 4. And it's going from -2 to 2. I could include at +2, but I'm not going to. I'm going to put that 2 into our final equation. Our final equation on the right for this piece here is actually very similar to the piece on the left. The only difference is this slope is now -3. So -3x, but now we also want to find our y-intercept, so we could do again y, this point here is +2, 4. So you can do y minus 4 equals -3 times x minus 2. And we get y minus 4 equals -3x plus 6. And we will see that we get y is equal to -3x plus 10. So 10 is here, and this is if, sorry, I forgot that, if x is greater than or equal to 2. Okay. So that one's a little bit difficult because we had to do a little bit more work to find the equations of our lines, but nothing you haven't done already back in Algebra 1. Please remember on your domains when to include the number and when not to. You cannot have an overlap or it is not a function.